You're listening to microbiology lesson on microbial applications in industry. So this is part 3, hopefully the last episode for this topic. I think I can finish it this time. We'll talk about the food industry. Now, in food industry, microorganisms can be a friend or an enemy depending on how nice they are to us or what we eat. They can be beneficial. Microorganisms can be applied to improve at least 3 things: the texture of the food, the flavor of the food, and the yield of the food, the production quantity of it. Microorganisms can also be detrimental. They can spoil the food outright or causing diseases in 2 ways. We'll talk about the 2 ways in a minute. Either way, the microorganisms can degrade the value of the food. And I don't mean value just as in how tasty the food is. I mean commercial value at industrial scale. For example, food can be delicious and fresh and healthy, but if microbes naturally cause your food to go off, to spoil after 2 days, maybe its value for local market is less affected, but its value drops significantly if you were to export the food overseas because it increases its logistical cost. And finally, there is a third category, which is neutral. We don't talk about this one that much because, well, what it means is if you run an assay and analysis, certain microorganisms can be detected in your food, but industrial players generally ignore it because it doesn't affect the value of the food industrially. It's neither beneficial nor detrimental. So let's circle back to the first type, the beneficial applications of microbiology. Microorganisms are applied in bread making, especially Saccharomyces cerevisiae, a type of yeast. We use them to leaven the dough, to give you the taste and the smell of the bread, to condition the dough. So dough conditioners can be yeast nutrients or enzymes derived from microbes. We add them to the dough to change the texture of the bread, for example, so that it's not too hard or too soft. So next time you buy bread, take a look at the ingredients to see what they have in there. I'll also leave some links about bread making later. Now, some of you might love cheese. I don't like cheese personally. If I order Subway, I'll ask them not to put the cheddar. But if you do like cheese, then you'd be grateful that we have bacteria around, especially lactic acid bacteria, LAB, which are commonly used in cheese production because it gives the texture, the flavor, and the aroma of the cheese. And at the industry, the microorganisms are applied precisely because they want to get the consistency of the cheese's texture, flavor, aroma, the cheese's personality, among different batches of cheese production. So check out the link about cheese making in the description. Of course, there are many other food products, especially dairy products, that rely on microorganisms in their industrial production, such as yogurt, sour cream, kefir, and buttermilk. Now, let's also think about the detrimental aspects of microorganisms as far as industrial food is concerned. Mainly, the microorganisms are the sources of food poisoning. We can make a distinction between 2 types of food poisoning. The first is food infection, and the second is food intoxication. Food infection is when you actually eat the live microorganisms in the food, and after you ingest them, they release toxins inside your body. Patients usually present with stomach pain, diarrhea, and one example is Clostridium perfringens. So they are gram-positive rods. They can form spores as well, which can be ingested. So study the link on perfringens that will leave for you. Perfringens is not super dangerous usually, alhamdulillah. When you get this food infection, your immune system usually will get rid of it even if you don't get any medical treatment. You just need to hydrate, to compensate for the fluid loss because of the diarrhea. The second form of food poisoning is food intoxication. Now, food intoxication is when you ingest the toxins themselves. So they can be enterotoxins, for example, spread by staph infection or staph contamination, Staphylococcus aureus, for instance. Or they can even be neurotoxins. Now, neurotoxins can affect your nervous system. The enterotoxin that I mentioned earlier, they affect intestines. So an example of neurotoxin intoxication is botulism. It can be caused by Clostridium botulinum. This one is more dangerous. It can even be fatal. It can affect vision. Your vision can be blurry, and some patients even present with speech impairment. There are many other examples. I want you to look at table in the Black's textbook and study them properly, especially if you are interested in food microbiology as a future career path. Now, to counter food poisoning, an entire system has been developed. The system is called HACCP, HACCP, which stands for Hazard Analysis and Critical Control Point. It's an international standard. Now, HACCP is founded on principles. For instance, throughout your chain of food production, you should conduct hazard analysis. You should determine critical control points, which are the steps in your chain of production where you can prevent the risk of food poisoning. And you take actions and then you document your actions. There are 7 principles. Study them. They are in that link. They are not very hard. They're quite intuitive. Also, take a look at examples of food safety tests in the Black's textbook. Table 27.4, test for determining milk quality. And it's a good one, pretty straightforward. For example, phosphatase test is used for evaluating the adequacy of your pasteurization because heat denatures phosphatase. So if you got phosphatase in your sample, it means that the pasteurization wasn't good enough, So, and notice also that in tests like that, we don't necessarily observe the pathogens directly. Instead, we look at the enzymes as proxies. And the important concept here is that you can't avoid contamination completely, especially at industrial scales. It's just unrealistic. So the primary aim of system like HACCP is to minimize either the presence of contaminants, or if that's impossible, it tries to minimize the negative effects of the contaminants that are present in the food. So you do this by preventing either the inclusion or the presence of microorganisms in your food in the first place, or you can create conditions where even if the microbes are there, they can't multiply, so that they can't reach a threshold population number where they can start to cause food poisoning. And to implement those 2 things, you can apply several methods. Number 1, application of antiseptics on your cooking areas and utensils. Number 2, hygienic procedures for personnel through training especially. Number 3, irradiation, like using gamma rays. So astronauts' food are usually irradiated because you can't really cook with an open flame out there in the space station. Number 4, thermal death time, which is a math concept on how long does it take to kill certain number of microbial populations at specific temperature. Because you don't want to prolong the process or overheat your food. You want to maintain its commercial value that I mentioned before. So you just want to heat the food enough to kill the bacteria with minimal impacts on your food's natural properties. Number 5, pasteurization, for example, HTST or UHT for milk. And number 6, the good old adequate time and temperature during cooking. In terms of preservations, you can apply methods like refrigeration, freezing, constant heat temperature or constant heat exposure rather above 60 degrees Celsius, application of salt or acid, and desiccation, you dry the food out. So at this point of your study, it should be obvious to you why each of these methods works. So in the exams, if you are asked, for example, why heat exposure above 60 degrees Celsius is useful to prevent food infection, why not 30 degrees Celsius or why not 100 degrees Celsius, right? So you should be able to answer it. Otherwise, you can go back to your textbook or the lecture notes to find the principles related to it. All right, Alhamdulillah, we're done for this topic. Listen to the 3 episodes again and check out the references that I've included throughout. Look at the textbook. Right, that's all. Barakallahu li wa lakum. Wassalamu alaikum wa rahmatullah.